Very good morning, everyone. Just a minute. Let see.
Good morning, sir.
Okay. You can hear
Morning.
me. Very good morning, everyone. Welcome back to this AI classes, and we have been in session 25, where the emphasis of the session is to introduce various inference mechanisms. This class will be some deviation from the earlier classes, which is a very easiest class that you have seen this in discrete mathematics. But inference management system is the most important system as far as AI is concerned. We have seen various types of systems. We call that systems as how do you design the rules. We call it as a production systems, or how do you propagate the constraint. We can call it as constraint satisfaction systems. We have truth management systems. At the same time, we have also inference mechanisms like inference management systems. Like if somebody asks me how does Sophia can interact with people, how can Sophia can understand the sarcasm, like whether this smile is a genuine smile or sarcastically they are smiling, how can it infer is based on the training that was given in the terms of how can she infer the data from the natural language. So this class can be the foundation for most of the people to know what exactly the inference mechanism will do. And apart from that, the inference mechanism or the rules that we discussed today are already discussed in your discrete mathematics in a different context. I have seen your syllabus of discrete mathematics just now, and apart from that, I have also seen the types of questions that you have answered in discrete mathematics. So this class will be in line with what you learned in discrete mathematics, but the intention of the class is how can you design a robust, adaptable, accurate inference mechanisms. Like I try to read a paragraph and try to answer something from that paragraph. What is the inference from the paragraph that we have seen in Capgemini? And today also we are having almost 6 to 7 people. We are having some interviews in DSX because yesterday the interviews are not completed. All the people, when they try to have an exam, the exam is they give a paragraph and they will ask you to infer something from the paragraph, which is very important. How do you read the paragraph, and how do you understand, how do you infer something is what your inference mechanisms do. And you most probably you might have remembered this, like when we are talking about the components of artificial intelligence, the inference mechanism was there. So you have seen that inference mechanism is a mechanism which can interact with the people and try to get some input and try to infer with more clarity and more confidence. The same thing will continue, but we will see the entire discussion like inference mechanism. We need at least 5 to 6 classes so that we wish to introduce all the mechanisms that are in the syllabus. Then we try to find out what is the best mechanism for what type of applications need this type of mechanisms. This is what the discussion that will happen for at least 3 to 4 classes from now. This is what the agenda is. Again, I will start the inference mechanism, basic inference mechanism today. And then all these things we have done for the last 4 to 5 classes. We have seen about breadth first search. We have seen the algorithm. We have seen the trace of that algorithm. And the same thing like depth first search, best first search, which is a combination of DFS and BFS. We have seen this A star algorithm, branch and bound a strategy, hill climbing and beam search that we have done. So intentionally I have taken this class to deviate all of you from these algorithms, because we have significantly discussed about at least 4 to 5 different type of algorithms in the terms of traces. Then it is your responsibility now to take your textbook and read what exactly why A star has come, what exactly is hill climbing, what is steepest ascent hill climbing, what are the disadvantages of hill climbing, why we are only getting local maximum, not a global maximum, why you are getting a ridge, why you are getting a plateau which is static for all the input, whether your input is x or y, you get a same value, why you are getting that, where exactly the algorithms are performing well, where exactly the algorithms are not performing well. So all these things you need some time to read the textbook. So that is the reason I deferred the discussion of algorithms or to at least 2 to 3 classes, so that you can open the textbook and just read this and come back. So this is what we have seen. The branch and bound algorithm is an algorithm which takes g of x as the heuristic. Hill climbing algorithm will take h of x as the heuristic, and beam search also takes h of x as the heuristic, but beam search is governed by a branch factor called w, like how many promising nodes can be explored at that moment. Is it 1 or 2 or 3? If it is 1, it is a hill climbing itself. So best first search talks about taking a heuristic in the terms of what is the promising node at that moment. So the same story we are doing for the last 4 or 5 classes, and this A-star algorithm talks about combining both of them and having a better heuristic which is suited for most of the applications that we have discussed. So my intention of writing all this heuristic is most of the algorithms that we study in the second unit as well as fourth unit, they differ in the way in which they choose the heuristic. In the summary of the last class, I said if you have a problem that has to be solved, you can have a different heuristics for the same problem, but the heuristic that you have taken has to be selected based upon how do you get the input, how faster you can get, how less processing you can do in the terms of time as well as space. So the earlier you get the output, the accurate output, what we call, because when we try to have a paths between some nodes, we will get more paths, but we are interested only the least path. So this is what we have discussed in the last class. So this class is a very simple class. I said you can see here Rama, we have set of statements and we need to infer from the statements is what the challenges of artificial intelligence is. So I said there is a story like A, B, C, D are the prime suspects of a crime. That crime is some murder has happened and these four are the suspects. And the challenge is everyone, like A has given a confession, B has given a confession, C has given a confession, and D has given his own confession in the terms of writing as well as in the terms of voice. They have recorded this. How does the system read that statement or read the voice and can infer then the sanctity and validity of the data that was given by the suspects? It's very difficult. And what type of questions we need to ask and what type of conclusions you can get in where exactly the data is inconsistent, where exactly we need to probe the suspect so that we can get a clarity to take some decision, is where your inference mechanisms will be used. So a small example I have taken, Rama is a boy. Rama was born in 1550 AD or some other day. There is a volcano that was erupted in 1600 AD and everyone died in that volcano. So what is the inference? Is Rama is alive? What is the inference that you can get from these four statements?
No.
No. So Rama is not alive. So no is a decision or the inference that you can take with 100% guarantee. So is there any chance that Rama is alive? No, there should not be any chance as far as these statements are concerned. Now you answer the second question. How many years Rama is alive?
We can't say.
50, sir.
We
Yes,
can't say.
We can't say,
yes.
sir.
We cannot make any inference. We can make the inference if some data is augmented to the four statements. That's what we can say. At this moment, based on the four statements, we cannot be in a position to make any inference regarding how many years that Rama is alive. If there is a chance, there is a statement like Rama has celebrated his 45th birthday in something like 1940, 19 something like that, then you can say 1595. If some statement is there like Rama has celebrated his 45th birthday on 1595 or something, if this statement is there, you can say at least 45 years Rama was alive, something like that. You can have a statement. So the two things are there in inference management system. One, inference management system, what it will do is it will try to conclude something with some accuracy. Sometimes it is 100 because all these are facts. Sometimes it will ask you about more information so that it can take some conclusions with 100% guarantee. Many times it has to take inferences from incomplete data, exploring some other inconsistent data. So this is what inference mechanism will do. But what is that you have done in your discrete mathematics is you have taken a statement. That statement can have either true or false. Rama is a boy is true. There is no chance that it can have a value between 1 and 0. So every time Rama is a boy, the value is 1, that is true. Rama is born in some date or some year, that is true. So whatever you have done in discrete mathematics is facts. So every statement will have true. As far as this class is concerned, we will also take every statement is valid, and we try to have inferences like this. Is Rama is alive? Is no is the answer, and the inference probability is 100. So this type of inferences only we are going to just learn. But the intention that this inference mechanism was kept in the syllabus is not to take inferences with 100% guarantee, or not to process data which is complete and which is with 100% probability. It is how do you take decisions with incomplete data, that is a challenging thing. So for that we need some fuzzy logic that we will discuss at a later stage. So for this title, I have done the justification now. The title is how do you think about inference mechanism. Inference mechanism is how do you process statements. So how do you process statements means some of the systems, they represent the statements in the terms of symbols and they try to infer. Some systems will read the statements and they will understand the statements, then they will infer. It depends upon. So we are going to witness some mechanisms where every statement is represented in the terms of symbols. From that symbols, we will just try to infer. So for inferring something in discrete mathematics, we have set of rules. You know that we have set of rules. We call them as rules of inference. And most of the people, if I type something, you will remember them. Like you have a statement called as P, which is a fact and which is a true. Can I or some statement and say this is also a fact? Can I do this? Is it valid or invalid? Or just tell me if P is there. I just AND this with Q. So what I'm just telling here is I have only one statement called as P. I know that P is true. When P is true, P or Q is true or P and Q is true, which can I take it as an inference, or which can I take it as a valid point? Is it P or Q or P and Q is true? Just leave it. I am just doing something different now. I have a statement called as P. I'm just Ring with Q. From this, can I conclude Q is true or P is true?
Yes.
Yes, what you said is right. So here I'm coming back to the earlier point where I just see I have a statement called as P. If I have a statement called as P, then I can take P or Q. This statement is also valid. So this statement is not valid. So this rule you have studied in your discrete mathematics as addition or something, but this rule says you know only one fact, you can R the other fact, so the combination is true. The second rule says, I just have this representation. You have two statements which are combined with P is a statement and Q is a statement. Is you have something called as AND here. I can conclude Q as a true, or I can also conclude P as a true. This is also valid. And in your discrete mathematics, this can be called as conjunction or whatever it may be. I don't remember the names, but I'm just typing. We'll see. Because I have a slide in the PPT to show all the rules, but I need to discuss. That is the reason I'm just typing here. I have something called as you have, if I have two statements now. I'm just typing here. This is a fact, and I have the other statement called as P. What can be the conclusion now? What is the inference that I can get from P? This is conjunction or bijection, that is symbolized. See, you need to mute yourself. Okay. Is this symbol is conjunction or disjunction? This is or bijection. What this symbol is?
Implication.
Oh, implication. What you said is right. Okay. P implication Q. If P, then Q and P. What can be the inference that you can get here? See, whenever this, what is the inference that you need to get is the what is that you can do is you can do something like this, which is informally. What is P implication Q? Yes. P implication Q is nothing but negation of what is the, I need a negation. A negation of P V Q. You can join two statements like this. This is something called as P. So what can be the output you can get? See, P and negation of P is true. So what is the inference that you can get from these both statements? P implies Q and P was there. You will get something called as Q. You have two statements called as P implies Q or implication Q, and you have a statement called as P, then the inference is Q. This is called as modus ponens or something like that. This is called as modus ponens. Now can somebody tell me like what will happen if you have something called as P2 Q, and you have something called as negation of P, or you take negation of Q. Negation of Q. You have these two statements. What can be the inference? Can somebody tell me? P implication Q was there and negation of Q was there. What can be the inference? See, this is what we have done in your discrete mathematics actually. Most of the people have
Negation.
negation.
Negation. P, sir.
What you said is right. You can do like this. Again, you can expand negation of P, negation of P V Q is what the expansion is, and you already have a negation of Q here. So obviously what will happen is this 2 will go and we will have only negation of P. What she told is right. The inference can be something like negation of P. So the interest that what we are discussing is you need to understand something like this. That something is when you are taking some two statements and you are inferring something, that is what your platform on which you are building actually. This is what you have done in discrete mathematics. I am doing it again. So P R Q and is a statement, then I will take not of P then. What can be the inference from these two statements? You can just join them by using R, then you will get the output. See, what is the inference? Yes, what is the inference from these two?
Q.
Yes, what you said is right, that is Q. So I do something like this one. Negation, if I write negation will come. What is that we do? Negation was there, okay. Then we'll go to the next rule then. Just we'll have a different rule. I don't remember the names of the rules, but the names of the rules are there in the PowerPoint. So what can be the implication here? P to Q was there, Q to R was there. What can be the inference?
P to R.
Yes. So the interest is not you are learning something about discrete mathematics. The interest is there is a two statements are there. The third statement is inference. So this 5 we can call it as hypothetical syllogism or whatever it may be, but these 5 are very important rules. Now we could see the PowerPoint which is displaying all the rules now. So you have a rule that if you have P, you can R any statement, and this statement is an inference and this is a fact. If P is a fact, P R Q is also a fact. So the name of the rule is addition that they have given. So this is what you have seen. And if you have two statements called as P and Q, two statements are there, you can combine the two statements by using AND. That is called as conjunction rule. So we are framing the rules in such a way that we can take some inferences or we can make some conclusions. This is what the aim is. So if you have a statement called as P and Q, you can infer either P or we can also infer Q. It depends. It is just a reverse. It is called as simplification. Just you can remember the name also, because sometimes when we are asked to See, what is an axiomatic system? Axiomatic system is a system which is based on the inference rules, and you will give an example, but then you need to write these rules also. So just remember the names of the rules also. So two statements are there, P implies Q and P was there. If these two statements are true, are facts that were given, then the inference is Q, that is called as modus ponens. So the same way, the same rule that was given in a different context with P implies Q and negation of Q, you said it is negation of P, and this rule is termed as modus tollens. So we have various mechanisms we call as axiomatic search or semantic tableau. Semantic tableau is entirely based on these only two rules. They will not accept any other rule. We have a search mechanism where you should not have this implication. So we will discuss that, but we will discuss the rules. Okay. Then we have PRQ. Negation of P was there. When you combine them, you combine with R, you will get this Q. This Q is called as inference. This is called as disjunctive syllogism. And hypothetical syllogism also, this is what it is. Associative rule, P to Q was there, Q to R was there. This can be the inference which is true. You are only talking about inferences which are valid because that is valid. So these rules also we can just see because P to Q means you need to expand it as a negation of P V Q, and R you have to apply this, and then you will get this like negation of P V Q, and then you just do an AND with the negation of R V S, then you just extend this, then you will get this part. But there is no need to remember that 8th and 9th rules, because 8th and 9th rules are a combination of all these rules. So obviously most of the time we will apply this 1 2 3 4 5 6 7. So the inference rules are very important while you design a mechanism, because the questions they will ask is something like this. This is what you have done. They will give set of statements like this. From these statements, can you infer S or not? They will ask you like this. So this is how, like the interest is you need to understand, like you have some mechanisms which will read the statements, convert the statements into this type of symbolic representation, then try to conclude. There are some mechanisms which will process the statements. From that statements you get these symbols like this, symbolic representation. From this symbol they will try to validate whether S is valid or not. The same way here, again 4 statements are given and you have asked whether this inference is valid or not. The same way here, other 4 statements are given. The interest is there is an inference that was made here. You need to validate that inference whether it is true or false. So now you just tell me, since the title is an inference mechanism, what is the output of inference mechanism?
True or false?
Yes. At this moment, the inference mechanism, see, I have 4 statements. I have asked whether S is valid or not. You have to tell whether it is true or false. But some inferences are there, like how many years Rama is alive, we cannot conclude, we cannot take any inference from this type of questions. You ask a question at this moment, that question can have an answer as true or false. These questions can be answered when you supply more information. even when you supply information also, there is a chance that you cannot answer these queries with either true or false. I said I have a statement that Rama has celebrated his birthday in 1595. Then there is a chance that Rama is alive at that point, or he might be alive till 1600. So how many years Rama is alive? At most he can live 50. At least you can have it for 45. So this 45 and 50 in between also you can have a value. So you cannot guarantee how many years Rama is alive. So you cannot answer the queries. Two types of things will be there in inference mechanism as far as 2-3 classes are concerned. You will have a true or false, and sometimes you will also have these questions cannot be answerable. This type of questions are there, this cannot be answerable. So inference mechanism, what it will do is it will ask many queries. It will ask you further information, and then it will try to answer based on some fuzzy logic. And every time that inference may not be right, or may not be reliable also. So this is what it is. So now coming to the back to the class, like we are given four easy premises, like four statements are given, and you have asked whether this inference is true or not. Can somebody answer this, whether can we get the inference from this? So four statements are given and you are asked to get a value called as S. Can you infer S from the four statements or not? So how can I start this? What are the statements with
Yes, sir.
yes, what you said is right, because I have taken very small examples. So you need to understand, when we are taking classes online, generally I am taking, or we are taking generally very simple questions, but once you try to solve the questions in the exercise, that level of complexity and difficulties will be different. So we have symbols with operators. I try to take uh, negation of R, because I feel this is a simple thing, because R does not have any operators which is connecting with only symbol, only one symbol it is that. So when negation of R was taken, what is the next statement I can take? Is it P implied negation of Q, or QVR, or negation of S implies P? What type of thing I can take here to get the output faster?
Q or R.
Yes, because a negation of R is there, better you take Q, R, R. So if you consider this is the first statement, and this is what the second statement that was given, the third statement can be what?
P implies negation Q.
Maybe, but what is the inference from 1 and 2?
Q, sir.
Yes. 1 comma 2. Whenever this type of inference mechanisms are asked, what that you do is you can combine them by using R. So the inference that you can get here is your Q. Inference from this is Q. Then how can I proceed?
P implies negation Q.
So Q is here, so then I take this P implies negation of Q here as my fourth statement, which is a fact. All these statements are facts. All the statements that we are taking are facts. All this you have done also. So what can be my next step? What is the inference from 3 to 4?
Negation P, sir.
Yes. Again, if you wish to apply rules, you can apply, or what is that you can do is you combine this 3 and 4 with R, because P implies Q is nothing but negation of PVQ. So what will happen here is, in general, just I'm writing informally, there is a Q. This Q I have taken from third statement, and you are this, you will have this negation of P, VQ will come, because there is a negation here. This is a negation. So Q V negation Q is always true. So what is the inference that I got here is negation of P is what my inference is. So fifth statement, I have a fact that negation of P is true. So my question is something like this. From all the statements, I need to infer whether you get S or not. So then how can I proceed now? Negation of P was there. Then?
Negation S implies P.
Yes, you take that negation S implies P. So what is the inference that you get from joining 5 and 6?
S, sir.
Is something like negation of P was already there. This was there in the fifth statement. So you can combine with R if you wish to, or you can apply the rule also, because rules are already there. So S SV negation of S. Okay, you will get a P here. So from this, what is the inference you can get is yes. So the interest of this class is not to solve this problem, but the interest is something like you have some natural language processing statements. You represent the natural language processing statements in the terms of symbols. From these symbols, we try to conclude whether S is valid or not. S is true or false. So you said S is an implication of all the statements. So S, the inference is right. Even though the problem that I have done here looks very simple, but when you try to process the natural language processing statements and try to infer, it's very difficult to have an inference like this. So just we'll continue the class, seeing the next set of problem that was given. All these problems that I have taken are from your external exams. This question, first 3 examples that I have taken are from external exams, and each question was surprisingly given for 8 marks. So again, the same story, we are given 4 different types of statements, and you are asked to validate a single inference. This is what we have been doing, and this is what we have asked to do now also. So this is what the question they have given. Again, the inference is yes. Is it right, or I have copied the same thing again? Again, the inference is yes. Okay. So now just tell me, if you have a piece of paper with you, can again this 4 statements will lead to yes? Just try to have some paperwork and just try to tell. So this is what the question is. Is the inference that S is valid or invalid? Is the inference is valid or invalid? S is right or wrong? S can be inferred from these 4 statements.
Yes, sir.
Yes. Okay, we'll proceed then. So how can we start? We generally take the symbols which are very less. That is the reason I can start with Q or R, but I prefer R. The reason is R was there, negation of R was there. There is a chance that you can get. So I take this first statement as R. and I will take the next statement as RVP. So the inference from statement 1 and 2 is what?
P, sir.
Yes, directly you are getting a P, so capital P. Okay. So what statement I can take then? When you have something called as P, better to take some statement which is related to P. Yes, Q2S. So what can be the inference from 3 and 4?
Q implies S, sir.
Yes, 3 comma 4. This rule is modest tolerance, like you have something called as P implies Q and P was there, you can get Q. The same rule that we have, rule number 4. We can get something called as Q is S. So I have also a statement called as Q. Now I will take this because Q to S was there. Q I have taken. What is the inference that you can get from 5 and 6?
S, sir.
Yes, inference from 5 comma 6 is, again I am applying the same rule. Rule number 4 that I have, rule number 4 you can change the rules because it was there as a rule number 4 that I have written. So Q to S, so the implication is S. So S is a valid inference. So all these questions I have taken are from your seniors paper. Just now I have seen your seniors papers, and these questions surprisingly they have given it for 8 months. So this is what the question that you can have, and we'll just conclude after this. See, this symbol is an and symbol actually. So I have to use this and symbol which is not there in the system. That is the reason I have copied here. Just try to validate. You have 4 statements that are given here, and can you arrive at R and PVQ? Just try to validate whether that is right or wrong. See, the inference is valid. I think this inference you can get because you can combine these two to get P. From that you can get PVQ is already there. If you get R, that is complete. Okay. Can somebody answer me now whether the inference is valid or not valid? Is the inference is valid? Just try to tell me. Is there any chance like you get something called as R from this 4 statements?
S, sir.
How do you get R? If you got R, obviously the problem is solved. See, just informally I'm writing, I'm not practicing the way in which I have to write. But see, what is the inference that you can get from these two?
Negation P, sir.
Yes, what you said is right. Negation P. What is the inference that you can get from these two?
Q, sir.
What you said is right. This is Q. What is the inference that you can get from these two?
R, sir.
Yes. I'm just writing R here. So R is a statement that is valid and PRQ is a statement that is valid. So you can combine these two with AND. So this is the rule. See here. P is a statement, Q is a statement. You can combine these two by using P and Q. So obviously R is a valid statement that you got. P and Q is a valid statement that is already there. So then R and PVQ is a valid inference. You got the answer now. So all these are very simple and most probably it will take less than 1 minute to do these problems. So I started like this. I just started combining this because the negation of P, V, M and these two will go, negation of P will come. P and P if I join Q will come, Q and Q to R because this is modus tollens, you will get R here. R is a valid statement and P2 is a valid statement. You can combine these two by using this and because there is a rule like this. The rule is very clear, like you have two statements, you can combine the two statements by using and. So that is the reason you can combine this. So this is what my class is actually. My interest of the class is, if you wish to summarize what actually happened in the class, we have different types of inference mechanisms which process sentences. They process the sentences and they understand in the terms of semantics and they try to infer. Some of the inference mechanisms, they convert the sentences into symbols and they try to infer. These two are the second type of inference systems. The first type of inference systems, they understand the statements and they will infer. Second type of statements, what they do is they convert the sentences into symbols and they try to infer. And we have some inference mechanism systems which will only follow very specific rules. Like in some in mechanisms, this implication operator is not valid. They should not use this except that any other operation is valid. Or in some mechanisms only this implication is valid and this and or are not valid. So we will see that type of systems. But what systems are there in the syllabus is, we have systems I2 and I3 within the syllabus. We have no systems in the syllabus which will process the statements and understand something and then try to infer. That type of systems were not there in the syllabus, but that type of systems are in demand now. What type of things are there in the syllabus is, we will be given some symbols and then we will try to infer. We will be given some statements, we convert the statements into symbols, then we need to infer. These two type of systems are there. So I feel since we try to design things and develop a system, so the types of AI systems are very important. What is production system, what is constraint satisfaction system, and what is inference mechanism system. So the basics of this type of systems must be there for every student. So obviously three different types of AI systems that we have introduced so far now. I start with production system. Then we also seen this how do you expand these constraints, we call this constraint satisfaction problem. And this is also very important. This is called as inference mechanism systems, where many types of systems will come into here. More than 700 systems will be there. And this is what actually the summary of this class is. So I stop here again, and most probably we will meet again on Monday morning, because tomorrow morning class will not be there. That will be taken on Monday, because we have some other assignments that has to be taken. So if you have any doubts, please just unmute yourself, or you can just try to join in the other class. Meanwhile, I will just try to download the attendance. Just stay for some time, because this attendance is very vital, and we are just finding some people are not attending the classes. And some other information is like, consistently, I don't know why this attendance is getting reduced day by day. Out of 194, I could witness only 144, which means that 50 people are absent, which is not healthy. That's what it is. That's what I feel. So